In lesson 81, we're going to look at complex numbers. And what that means, in the past we've talked about how you cannot have a radical in the denominator. So if we've had something like 3 over radical 3, we had to change that because we could not have a radical in the denominator. So we multiplied by radical 3 over radical 3 and got 3 radical 3 over 3. When you multiply all that out. Now we're going to look at a more complex situation where I is in the denominator. Remember, I is the same as the square root of -1. So we cannot have a square root in the denominator. In order to cancel that, all you got to do is multiply by the conjugate. Multiply by the conjugate to change the denominator. Conjugated denominator, that is. So the conjugate of the denominator, if you remember conjugate, that means just switch the sign in the middle. So this becomes 4 plus 2i over 4 plus 2i. Notice that we're just multiplying by 1 because 4 plus 2i over 4 plus 2i is 1. So when we multiply, we FOIL. So first, 2 times 4 is 8. Outside, 2 times 2i is 4i. Inside, 3i times 4 plus 12i, and last, 3i times 2i would be 6i squared. We'll simplify that in a moment. The bottom would be first, 4 times 4 is 16. Outside, 4 times 2i plus 8i. Inside, minus 2i, or negative 2i times 4 is negative 8i. And last, negative 2i times 2i would be negative 4i squared. So what you notice when we multiply by the conjugate, okay, and FOIL, the outside and inside will always be opposite and cancel out. What that will do for us is leave our denominator with no radical. Because when we simplify, what happens, okay, 6i squared, remember I squared is the same as -1. So 6i squared is actually a -6. Negative 4i squared would be a positive 4, because I squared is -1. So now we add 8 minus 6 is 2, 4i plus 12i is 16i, over 16 plus 4, 20. We can reduce this. This is the same as saying 2 over 20 plus 16i over 20. So we reduce 2 over 20 is 1/10. 16 over 16i, 2 goes into that, 8 and 10 times. So you could say 1 plus 8i, 1/10 plus 8i over 10, or you could say 1 plus 8i over 10 like that. These are the same thing, and that is all there is to complex numbers.